In this video, we take a look at primary and foreign keys, focusing on them and making them easy to understand. So what is a primary key? A primary key is used in a database table that is unique, meaning it only appears one time. It uniquely identifies a set of data. So let's take a look at an example of a table with and without a primary key. So here, there's no primary key, and there are some things we need to consider here. John Smith in the table may be the same person, which means we have data redundancy. I say John Smith appears twice. They may be the same person, or John Smith listed in the table may be two different people that just happen to have the same name, the same birth date, and they chose the same major. Without a primary key, it is impossible to tell. Now, if they are two different people and John Smith unenrolls, we won't know which John Smith we need to remove. If it's the same person, we'll go ahead and remove John Smith, but he's still going to be in the table because of data redundancy, and this leads to data inconsistency. So we need a primary key. Student ID. 1001 refers to John Smith. 1002 refers to a different John Smith. 1003 refers to Susan. 1004 refers to Walter. So now we know certain things because of the primary key. We know there are two different John Smiths. 1001 refers to one John Smith. 1002 refers to a separate John Smith. They are two different people. Now, with a primary key, this will prevent data redundancy from occurring. Let's take another look at another example without a primary key. So here we have first name, last name, the department they work in, and the role. So we have Rick, we have Julie, we have Beatrice, and we have Max that work at some company. Now, we have some things to consider here. Do we even need a primary key? Well, I see everybody has a different name. Everything looks good. We don't need a primary key. Wrong. We do need a primary key. Now, you may be saying, I don't see anyone with the same name. Sure, I see the same occupation, but each name is different, so it doesn't matter. I ask, is it possible for another person to join this company that has the same name, works in the same department, and has the same role? It is possible. By adding a primary key, we eliminate the possibility of data redundancy and data inconsistency. So by adding a primary key, employee ID, it doesn't matter if somebody shows up with the same first name, the same last name, works in the same department with the same role, because they'll have a different employee ID. So a primary key eliminates data redundancy and data inconsistency. Now, what is a foreign key? What is its purpose? Now, a foreign key is an attribute in a table that is a primary key in another table. They have and they do represent the same value. A foreign key must be a primary key in another table if you're going for normalization, which you should be doing. Now, we talked about that in a previous video, how to normalize database tables. This helps create normalization, the use of a foreign key, and linking different tables together. Look at this table. There are some things we need to consider here, and there are some problems that could arise. Let's talk about those different things. What if we change mathematics to just math? Well, now I have to go through the entire file. We got to try to find all instances of mathematics and make those changes to change it to math. It is possible that I could miss some of those. The major attribute, also a separate problem, has nothing to do with a person's ID, nothing to do with their first name, nothing to do with their last name, nothing to do with the birth date. First name, last name, birth date. These attributes depend or tie to the student ID. They all tie to a unique identifier. Now, your name does not have to be John in order for you to major in mathematics. Your birth date doesn't need to be January 23rd, 1991 to major in computer science. These majors have nothing to do with these other attributes. So we need to split the table so we can normalize it and implement the use of a foreign key. So we need to move the major to its own table. We'll have a new table that has a primary key that identifies each major. And here it is. We have major ID, M1, M2. It uniquely identifies one major. If I want to change mathematics to math, I only need to do one update because M1 corresponds to mathematics or math if I choose to change it. Now, we can now add majors to this table without affecting the student table. I can add another major. I don't have to go through and worry about the student table at all. The same is true for the student table. I can add as many students as I want here without affecting the major table. So we now need to link them together. So we have our two tables and we can link them together through a foreign key. Now remember, all attributes should depend solely on the primary key. We visited that more in the normalization video. We will need to create a third table that will link these two tables together. Because if you remember, we had John's, they were majoring in mathematics. Susan was majoring in computer science. And I think Walter was majoring in science or chemistry. Here I added a third one. I can also change it if I need to. So here we go. Our third table will consist of a set of foreign keys because we've got to link these tables back together. If I just get rid of the major, which I have done, I've now lost information. I need to link these tables together so I know what each student is taking. So what can we use as a foreign key from our student table? Well, remember, we must use the primary key student ID. So this is going to be a foreign key in my third table. What about from the major table? I have to use the primary key, major ID. So we have discussed we need a primary key for our tables. But what about a third table? We just said we're going to use student ID and major ID, so which one becomes the primary key? Well, it can't be major ID because student ID is not dependent upon the major ID. And well, it cannot be student ID because major ID is not dependent upon student ID. So what do? Well, we can use both and create what is called a composite key. And a composite key is when more than one attribute is chosen as the primary key, because the primary key should be unique. This means each row, I will never see the same data appear more than one time. So let's take a look at our final three tables, implementing primary and foreign keys, and link those three tables together. So here is my student table. Here is my major table. I need to link these tables together. And here, I've changed M3 from science to chemistry. I have to go through and find all instances. I just needed to do it one time. So now, I need to implement a foreign key. And here's my third table, the use of foreign keys. This is a composite key, which means the same two sets or two rows of data here, or two columns of data, there will never be a repeat. Each row is unique. M1 appears more than once, but because it's a composite key, we have student ID 1001 taking M1. We also have 1002 taking M1. So this allows me to see the major they have chosen. Now, we have our primary key, student ID. We have our primary key, major ID. We have our primary key, which is a composite key, student ID and major ID. And student ID is also a foreign key because it relates to the primary key in our student table. This student ID and this student ID, they represent the same thing and they have the same value. Major ID, it's also a foreign key. It represents the same major ID inside my major table. They have the same attribute, they have the same value. So that's going to be the broad strokes for primary and foreign keys. I hope you found this video helpful. If you did, make sure you give a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next video.